Hello everyone, welcome back to another exciting chemistry video from Adrenaline the Bazooka Prophet. Have you ever wondered how batteries are used to generate electricity? Now, at the end of these video lessons, you will be able to know the differences between electrolytic cell and electrochemical cells and real life applications of it. Now this video is very important for students who are preparing for exams. Now on the board is what we call the electrolytic versus electrochemical cells and their comparative or studies. As you can see by my left here is a typical example of an electrolytic cell, and by my right is another typical example of electrochemical cell. Are they the same? No. Do they have some difference between them? Yes. And in this video, that is our sole aim and focus, to demystify and unravel the salient secrets between these two cells, electrolytic cell and electrochemical cell. Now let us talk about it. Now, what is an electrolytic cell? Simple. An electrolytic cell is a cell that simply converts electrical energy to what now? To a chemical energy. Take note, in the case of electrolytic cells, it helps to convert electrical energy to what now? To chemical energy. Or we can simply say it uses electrical energy to drive a non-spontaneous reaction, whereby in the case of an electrolytic cell, there must be an external source such as a battery. If not, it is not going to occur. If not, it is not going to work out. Unlike that of the electrochemical cell, which converts chemical energy into electrical energy through a spontaneous reaction. Now, I often tell my students all over the world that for a reaction to be spontaneous, it simply means it can occur by itself, meaning there is no external power or external source necessary for it to occur. And we should also understand that the other name of electrochemical cell is also called a galvanic cell. And a very good example of galvanic cell is the Daniel cell, in which in our subsequent series of this video we'll be talking about all these and breaking it down. And please, if you have not yet subscribed, do well to subscribe to my channel or wherever platform you are looking to watch me from. And if you want an online classes, you can as well send a DM to this number for an aggressive online tutoring. Now we go straight away. We should understand that this is a very typical example. Let me explain. Now you can understand that in the case of electrolytic cell, we just have one container, while in the case of electrochemical cell, there are two containers, as you can see. Now look at it here. This is the anode. The anode, in the case of electrolytic cell, they are positive, while the cathode is negative. Unlike that of the electrochemical cell, where the anode is negative, the cathode is positive. But needless to say that there is a very important part I should let you know from here. It is a shortcut which I should let you know from here. We should understand that there is something we call Pro-A. Reduction occurs in the cathode, oxidation occurs in the anode. Don't forget, reduction occurs in the cathode, while oxidation occurs in the anode. Now take note of it. So it means that in the case of electrolytic cell, the anode is positive, the cathode is negative. In the case of electrochemical cell, the anode is negative, but the cathode is positive. Now, don't forget, if you look at the flow in both of them, the flow of electrons in an electrolytic cell is from the anode. You see the flow? Is from the anode to the cathode. You see? Anode to the cathode. Anode to the cathode. What? In the case of this one, if the electron flow is from the anode to the cathode, the current is not the reverse. The current is from the cathode to the anode. Do not forget. Now we now move straight down to, now we now understand that in the case of electrochemical cell, it is a spontaneous process. But in the case of electrolytic cell, it is a non-spontaneous process. And take note again that in the case of electrolytic cell, it requires an external source, such as batteries. But in the case of electrochemical cell, it is not like that. It doesn't require any external source. Why? It can generate electricity by itself. Now, when we go deeper into this place, we understand that if you look at the electrochemical cell, we have something like, look at a U-tube here. A tube which is in an inverted tube. What you are seeing there is what we call a salt bridge. Do not forget. Now, what does salt bridge do? Take note. A salt bridge allows the flow of what now? Of ions. It allows the flow of ions, but prevents their missing. It prevents the missing of these two solutions or these two electrolytes. It doesn't allow them to miss, right? But it allows the flow of ions. Again, too, a salt bridge helps to complete the what now? The circuit, and also maintains electrical neutrality by preventing the reaction from stopping. You should get this fact and point, but it will make a lot of sense in our subsequent series of video on this topic. Exactly. You see the way it is now. Now, the major point here is that what are the components of a salt bridge? We should take note. It consists of an agar, and also a potassium chloride or sodium chloride, but an agar solution. Take note. It's a major question. An agar solution and potassium chloride or sodium chloride. And that marks the end of this particular video. We are on to the next one. Thank you and God bless you.